In this section, we're going to talk about what happens when you change matter. And matter can be changed in two different ways. One of them physically, the other one chemically. So they're very different. And if you change matter physically, all you're really doing is changing the form of it, but you can change it back. So an example of that would be freezing and melting water. So if you take a glass of water, put it in the freezer, it's going to freeze. If you take that ice out of the freezer, it's going to turn back into water. So changing states of matter would be an example of a physical change. You can change it back to its original form. If matter is changed chemically, on the other hand, it cannot be turned back to its original form because a chemical reaction has occurred and you have created new products. An example of that would be fire. If you take a log, you burn it, you can't get that log back to its original state. So just a little bit about physical changes. An example of a physical change, like I said earlier, is melting, freezing water. So any kind of phase change that you go through would be an example of a physical change. If you cut a piece of paper in half, you still have paper, you just now have two pieces of paper, so you didn't change the chemical composition of that paper. Also, breaking glass, all you do is have smaller pieces of glass. It's still glass. It's still the same chemical composition. The properties remain the same. All you're doing is changing the form without changing the identity of the substance. On the other hand, chemical changes, it's the process that involves creating or making new substances when you have that change occur. So those new substances have completely different chemical properties than the original substances. The major signs of a chemical change, and this is really important, if you see a gas forming, you know a chemical reaction has occurred, which means that a change has occurred. If there's a color change, an odor change, heat or light is produced, that one's very apparent in fire, and what's called a precipitant, which is the formation of a solid where there was no solid before. It's really important to note, though, color is a physical property of a substance. As an example, my eyes are blue. That is a physical property of my eyes. But if you have a chemical reaction and you see the color change from one color to another, that is a chemical change. So color kind of goes in both those categories. One of them is a change, one of them is not. It's just a property. Same with odor. When you have no odor and then an odor is produced, that is a chemical change. Some substances have odor associated with them. Earlier I talked about bromine having a bleach-like odor, but if bromine were to undergo a chemical change, that odor would change as well. So it's about the change. So those are very specific signs of a chemical change that you'll have to look for in chemical reactions. So an example of a chemical change is when you take sodium metal, add it to chlorine gas, and produce table salt. So each of these substances has specific physical properties. The physical properties of sodium metal, we've already talked about those. It's shiny silver. Chlorine is a yellow gas. Those are all physical properties of the reactants that are coming together to form the product sodium chloride. Sodium chloride has completely different properties than the reactants that formed it. It's white, it's granular. You can eat it. You cannot eat sodium metal and you cannot eat chlorine gas, but you can eat table salts, which is sodium chloride, the combination of the two. So a chemical change has occurred here because there's a clear color change. It formed a completely different substance with completely different properties than the reactants that formed it. So you can clearly see that a chemical change has occurred just by looking at it, just by the physical properties of each of these substances. So let's just go through 4 different examples to clarify the difference between a chemical and a physical change. So if I were to rust iron, when you rust iron, what you're doing is you're taking iron and you're introducing it into an oxygen-rich environment. That iron reacts with the oxygen. Each of those substances has specific properties, but then it forms what's called iron oxide, which is a completely different compound than the iron and the oxygen alone. So because it forms a completely different compound, that compound has a new set of characteristics associated with it, or new properties, therefore it has undergone a chemical change. You cannot unrust iron. Once it's rusted forever. Burning a log. So you cannot get that log back once you burn it. The best way to determine if something is a physical or chemical change is ask yourself, can I turn this back into its original form? Once you burn the log, the answer is no, you can't. That means it's a chemical change. Melting ice. I can put that water from the melted ice right back in the freezer and re-solidify it back into ice. So by changing those states of matter, that's just a physical change because you can go back between the two. Grinding spices. All you're doing is you're taking that spice and you're making it smaller. So no, that's not a chemical change because it has the exact same properties. If I grind up some dried basil, all I have is smaller pieces of dried basil. It's still basil. So it has undergone a physical change, meaning that I just changed the form of it, but I didn't change the actual composition or the substance and the characteristics of that substance.